Hi, I'd like to welcome everyone to the ESPRIT Probing webinar. I hope everyone can hear me right now. So we're going to go ahead and get started here. Let me go ahead and make sure my screen is showing. All right. So yeah, welcome to the ESPRIT Probing webinar. My name is Kevin Wismer. I am an applications engineer for DP Technology, and I am going to be going over the ESPRIT Probing functionality within ESPRIT 2000 series. All right, so as you all know, probing is a great way to quickly and accurately measure your parts while they are on your machine. It is great for not having to take a part off of your machine, reduce the amount of time for taking a part off and measuring it. It's great for being able to establish datum points. You're able to update work offsets effectively and accurately. And like I said, it's a great way to avoid having to pull your part off on the machine and do measurements. And it'll improve your rigidity of your processing of your parts, and it eliminates and minimizes any sort of errors that could come about from manually measuring your parts as well. So in the ESPRIT probing functionality within the ESPRIT 2000 series, we've included the ability for basically fully supporting your probing cycles. The processing that it encompasses is essentially creating your probing tool first. Then you'll go ahead and select the probing cycle, whichever one is appropriate for the toolpath that you're looking for. You then have to set some of the parameters for that probing cycle. This includes defining different clearances, whether it's a lateral clearance, the depth of the probing operation. Once all of the parameters have been set correctly, then what you'll do is you can go ahead and simulate that probing cycle, which is great for making sure that the probing toolpath is doing exactly what you would expect. It's great for collision detection as well. We do recognize collisions with stock or with the part itself. And then once all of that is correct, you're able to post out the code for your probing cycle. So the first thing we're going to talk about is creating the probing tools. There are 3 different types of probing tools that you can create. There's the ball stylus, the disc stylus, and then if your probe doesn't match either of those profiles, you can define a custom stylus. The most common one that we see used is the ball stylus. So I'm going to go over defining a ball stylus in the webinar today. So when you're defining the stylus, on the general page, you're going to go ahead and call the stylus whatever you need to call it. Give it a tool ID, just like any other tool in ESPRIT. The probe type, as you can see on the right there, that's actually defined within what's called the probe setup, which we're going to talk about here shortly. But within the actual tool definition, you have the ability to define your holder model. The ESPRIT probing function comes with finisher models that are preloaded. And when you can switch between those, and in simulation, you will see the difference between the models. You can define what's called a lateral clearance here on this page as well. This is just going to be a default lateral clearance value. And when you're actually defining that within the operation, it will default to this lateral clearance. You can then always update that lateral clearance from within the operation if need be. But we recommend putting in your most commonly used lateral clearance there. The signal time per touch there, that's going to just be, you want to input however on the machine, however long your actual signal time is for the touching, you'll put in there. It's used just for cycle time calculation. So for an accurate cycle time calculation, you want to make that as close as possible to what you see on the machine. Okay, then on this stylus page here, so you can define the ball diameter there, your shank diameter and your stylus length. The default depth there is an important value. This is going to be the default depth that's used within the actual probing cycle. So when you're defining the probing cycle parameters, this default depth is what it's going to default to. So that's going to be your most common depth value that you want to use. It should be at least the radius of the ball, and it shouldn't really be more than twice the radius or the diameter of the ball itself. All right, so the next thing is going to be defining your probing setup. From within ESPRIT, when you go to the probing setup page, it'll open up a little window that looks like this, and this is kind of an overview of the different tabs that you'll see on that window. On the first tab, this is where you can define your actual probe type. So we're going to be using a Renishaw probe today. The next setting on the general tab is going to be called Use Dedicated Post. The probing function comes with what are called embedded posts, and these are separate from your actual machine post. It's essentially an intermediate post that basically minimizes the amount of modification to the post that you're using. So it is separate. You'll still have your machine post, and it'll output all of the probing cycles. You do have the option to also customize this embedded post. So if you need to make slight changes, you can open it up, make those slight changes, and we will talk about one example of that towards the end of the webinar. There is an option for not using a dedicated post. That would be if you're going to use your open source post or a custom post. That would require you to modify it to include all of the probing cycles and routines within the post, and you would probably need us to modify that for you. You would have to contact inside sales, and we can get in touch with you about doing that. One nice function that we've added is the ability to output block delete numbers. So you can do it at all probing operations. There's a couple different options for where you'd like to output those and how they're output as well. On the cycles tab, we have some options here. And one big one is going to be what's called that rectangle cycle there. The Renishaw probes, some of them have an option for what's called a 5-point rectangle. And so when it's doing this rectangle cycle, you have the ability to touch on one of the sides twice. By default, it's turned off because it is an option, but you do have the ability to turn that on with that checkbox there. The next tab is going to be the NC output, and you can kind of control how things are output when you post code. One of the big things here is going to be the inch value and metric value, the amount of trailing digits that are used for those. So you can, if you only need, let's say maybe 4 trailing digits for inch and 3 for metric, you can always update it right here, and it'll give you the ability to kind of control how many trailing digits are being output. And then on the last tab there, you have the ability to see a preview of how the NC code is going to be output from when you're defining the actual probing operation. And you have the ability to just get like a general preview or to use your local plane coordinates or the local work coordinates so you can see the actual values that will be output. Okay, so next is going to be the probing cycles. One thing that I didn't mention for the Q&A portion, so we're limited by time here and there's a lot of people in here. So what we've done is you should have the ability to ask questions within the GoToMeeting webinar interface. So we have a couple people on standby here that are going to be answering questions. So if you want to go ahead and submit your question when it comes up, go ahead and do that and we'll kind of answer that as they come. We're going to try to answer as many as we can. We are limited a little bit here by time, so just keep that in mind, but yeah. All right, so we're going to start talking about the probing cycles. So there's quite a few probing cycles within the probing function here. We're going to go over most of them. We're going to go over all of them, but I'm going to go over in depth the most commonly used ones. So the type of probing cycles we have here, the common ones are going to be like doing a bore or boss probing cycle, the 3-point bore and boss probing cycle. The single surface is going to be a single touch point probing cycle. Web and pocket is going to be a 2-touch point probing cycle for measuring between 2 either interior faces or exterior faces. We have a corner cycle. And those are going to be the ones that I'm going to go over more in depth. And then the rest we have like rectangle, the XY angle for measuring angles of a certain face, bore/boss on a pitch circle, which allows you to measure some information about like bolt hole patterns and things like that. And then a rotary axis measurement is a 2-point touch cycle that will allow us to measure any sort of rotary angle. One thing to keep in mind is the probe orientation is controlled by the active work plane. So you're going to want to make sure that that is set up correctly before you actually select the cycle that you're going to use. Okay, the first cycle I'm going to talk about is going to be the bore or boss cycle. This is going to be a 4-touch cycle, and if you do have, so it's a 4-touch cycle. There's going to be 2 touches along the x-axis and then 2 touches along the y-axis. The preferred selection is either going to be a cylindrical face or the loop of that bore or boss feature. So I'm going to go ahead and bounce into ESPRIT here. And in ESPRIT here, we can see I have a bore cycle here. I'm sorry, a bore feature here. So to set up a bore cycle, what I'm going to do is I'm going to come up here. I have my probing toolbar here. And I'm going to go ahead and select the bore boss cycle. So first thing we'll see here is the general page. You can name the operation whatever you want, just like in any other ESPRIT operation. You'll want to select your tool ID. Right here, the XY feed rate and Z feed rate, these are not the feed rates that are used for touching. These are going to be the feed rates that are output for the protected mode. So just keep that in mind. And then we have the total depth here. This is the default depth that's set within the tool. I'm going to move on to the probing cycle tab here. And under the probing cycle tab, we have some options here. So first thing I'm going to do is I'm going to go ahead and select the probing element. This is going to be selecting what I want to probe. So right here, I'm going to do the external of this boss feature here. And once I select one of those faces there, you can see it gives me a live update of what that toolpath, that cycle is going to look like. You can see it outputs the element coordinates as well. We get the bore or boss of that diameter and then a total depth option there. One of the nice things here is the bore/boss diameter here. Right now it's reading out the exact diameter of this boss feature. If there were stock still on this, let's say it hadn't been finished yet, but we still wanted to probe it, I can always adjust that. I can add some value here. So let's say I have 20 thousandths extra material there right now from a roughing operation. I can type that in there and it actually updates my cycle here. And you can see an active or a live update of that. And here we can kind of see a preview of what that code would potentially look like. I have my total depth here that I can change, again, being pulled from the tool itself. That's the default depth. If you need to change it, maybe make it slightly larger, you can have that and we get an active update there. And there's ways to control external clearances. So right now I'm giving 50 thousandths clearance for, that's going to be my lateral clearance where it's touching there. If I were to zero that, we can see that kind of update. You can see it's just coming down directly on there. But if I give it 50 thou clearance, we can see that update in the toolpath. So I'm going to go ahead and hit OK. And what I can do is I can begin that simulation. Okay, we can see the probing tool come in. And start touching off on all four sides. I did define a clearance value so that I'm clear of this part here. And then what I'm going to do next is I'm going to define a bore cycle for this internal bore here. So again, I come up to my probing toolbar here, and I'm going to select the bore/boss probing cycle. My general page should be good here. It brings in all those values that I just defined. And then here, my probe element, I'll select the interface here. And you can see it actually recognizes this now as an internal probing cycle. So it recognizes this as a bore. And if I want, I can increase this depth a little bit. And if there were still material on there, I can adjust this value here to account for any sort of material that may still be on the walls of the bore. And if I hit OK, we can see both of my operations here, and I can go ahead and simulate again. And that's the two cycles I just defined. One thing I do want to point out is if I don't define a clearance value, so it will recognize a collision. So I'm going to go ahead here and set up a collision just so that you guys can see that. So I'm just going to use a clearance value here, and I'm going to define my clearance value as something small. Runs through the first cycle. Oh, doesn't look like it wanted. So it cleared there. All right. We'll try to get a collision in one of the other ones here, but it does recognize collision detection. Okay, the next cycle I'm going to talk about is going to be the 3-point bore/boss cycle. This is going to be a similar cycle, but it's going to be only a 3-touch cycle for when you can't use the 4-touch cycle. Similar selection input, so we can define a cylindrical face or a loop. And we can then establish the 3 specific vectors that we want to use. So if I go back to ESPRIT here, this time I'm going to select my 3-point bore boss cycle. The general page is going to be pretty similar to the last cycle. I'm going to move on to the probing cycle tab here. I will select the probing element I want to use. It's going to be this interior face here. And what you can see here is it sets me up with 3 vectors here. Now, I don't think I'm going to get some touch profiles here, so I may need to adjust the vectors. I'm going to try to change them so that they touch on this face here. What I can do is come up here to this vector angles section, and I'll do maybe 80 degrees and minus 80 degrees. And as you can see, it updates that preview, and you can see that nice probing cycle. Again, you get the ability to define the actual diameter of your bore or your boss feature. And I'll say OK, and we can take a look at that. So that is the 3-point bore cycle. The next cycle I'm going to talk about is called corner. This is going to be measuring a corner between 2 faces. Whether the faces are intersecting or not, it'll still measure them. It's going to be a 2-touch cycle. You do have the ability to do a 4-touch cycle, and I'll elaborate on that once we get into the actual operation. And here are the different selection methods. Typically, you can either use the 2 actual faces, a vertex between the 2 intersecting planar faces. So let's go ahead and take a look at that within ESPRIT. All right, I'm going to use that cycle to measure this corner here. So what I'm going to do is I'm going to come up here to my corner probing cycle. All right, I'm on the probing cycle tab here. I'm going to select my 2 elements. And let me just go ahead and 0 these out first. Select my 2 elements. And I get a 2-point touch cycle there for defining that corner. You do have the ability to define a second touch for each side there. And that'll be output as an I and a J value within the posted code. And what we can see here, if you watch down where the preview is, I'm going to say maybe we're going to do a secondary touch at 0.35 and do the same thing over here, 0.35. And you can see it updates that toolpath to include that, and it also updates the preview down here in the operation. I'll say OK, and if we want to go ahead and simulate that, 2 touches on each side. And that is the corner cycle. All right, this one here is the single surface, and it's just going to be a single touch cycle. Preferred selection is going to be a planar face or a cylindrical face. And this one's going to be used less for measurement and more for updating work offsets. In this cycle, you do have the ability to, once you touch up on that face, define a work offset to update. That's going to output the work offset update in the actual posted code. It doesn't affect your actual work coordinate in the ESPRIT file. So when in the programming side of things, it won't update that work coordinate, but it will output the code in the probing cycle in the NC code to update it. So the next cycle here is going to be web pocket, and this is going to be used to define or measure between 2 faces, whether they're interior faces or exterior faces. And so we can go into ESPRIT here. I'll show you this one. So here's the web pocket operation. So first I will do 2 interior faces. We can see here a preview of what that toolpath will look like. And again, you can adjust your web pocket width, the total depth, things like that, and you get a nice little preview of what the potential or the output code will potentially look like. And then also here, what we can see is I'll do an external profile, and for the selection input for that, I'm just going to go ahead and select the outer loop here of this. So I'm going to measure between these 2 faces here. And you can see it automatically recognizes that as an exterior measurement between those 2. And yeah, so a loop is also an acceptable input for this cycle. And I'm going to go ahead and just simulate that so you can see those 2. So there's my interior faces. And then if I come across, and it looks like we violated the stock there. So if I can hit OK. It looks like maybe I just went a little bit too deep there on my total depth. So what I could do then is I could then back off my total depth a little bit. So if I go into this operation, total depth instead of 0.1, I'll do 50 thou. And if I resimulate that, I should have corrected the issue. Violated stock. You know, we may be coming down directly on that stock there, so I may need to give myself a little bit more lateral clearance as well. And now you can see I have more lateral clearance there, and that should correct those collisions as well. So I'm going to move on here to the next operation. Next is rectangle. This is going to be a 4 or 5 touch, depending on if you have the option cycle. It's going to be good for measuring, let's say, your starting stock. Just go ahead and probing that measurement, and then also probing the actual size of 4 different touch profiles. Like I said, if you turn on that 5-point rectangle cycle within the probing setup, you will have the option to define which side you want to do a 2-touch, and then all the other sides will be a single touch. The next operation is the XY angle operation, and it's for it's a 2-touch cycle, and it's for measuring the angle of a face with respect to the x-axis. You can input either the loop of the face like you see with this image here, or you can select the actual face itself. Either are valid inputs for this cycle. The next cycle is going to be the bore-boss cycle. This is going to be for measuring the distance between bolt hole patterns. You can see each one of those holes there has actually, it does a 4-touch cycle within each hole. And then you can also measure the angle between the holes. So there's a lot of different data types that you can pull from this cycle as well. You can select for the input here, you can select either the face that that bolt hole pattern is on, the cylindrical faces of each bolt hole pattern, or the loops of them as well. Next is the rotary axis measurement. This is a 2-touch cycle. This is going to be used for measuring basically the angular deviation between your rotary axes. You can select a planar face here or the loop of the face as well, either as an or a valid input. So next we're going to talk about post-processing. So the probing function within the ESPRIT 2000 series does come with what are called embedded posts, and we had talked about this a little bit. They're an intermediate post separate from your machine posts, and they are made to minimize the amount of changes you have to actually make to your post. We do recommend using those if you can. If you need to update an existing post, if you're maintaining your own open post, or if you have a custom post from us, it will require some work to get that to support the probing if you're choosing not to use the embedded posts. The last concept here is going to be customization. You do have the ability to customize the embedded post, and I'm going to go over a quick example of how that would work. So first, for the dedicated posts, no changes really need to be made besides maybe customizing some of the output. What I mean by that is when you do the custom embedded post, one example would be for the default FANUC custom post outputs a G65 for the cycle types. However, a Doosan machine actually takes an M165, so you can kind of quickly go into the embedded post for that and change the G65 to get an M165 output. So if you are using the embedded posts, you do have that kind of ability to customize the posts themselves. Most of the ESPRIT corporate posts are already updated to support the Renishaw probing cycles. And if you need your post updated, you can contact Inside Sales and we can take a look at your post and see what kind of updates need to be made. So this is an example. If you are customizing the embedded post, on that probing setup, you can select the customized copy of embedded post. It will actually open the embedded post within your NC editor, whether you're using the ESPRIT NC editor or your own. And then from there, you can adjust the post. We've actually simplified the posts a lot. There's a little bit more code, but the actual, all of the cycles are simplified, so it's much easier to read when you are doing the customized posts. So it isn't really too hard to update the post just to get the specific output that you are looking for. If you are going to update your own post, there is a little bit of work that's involved. It's not too complicated, but it does involve just adding a couple of the extra routines, probing routines that'll be necessary. And this is kind of an overview of what that's going to entail. So there are some changes that you need to make to example cycle start, cycle end, example rapid. But yeah, it's nothing that isn't out of the realm if you want to do it yourself, or you can contact us and we can do it as well. We'll take a look at what kind of work the post needs and go from there. So I think we've been answering some questions that have been coming up. So I'm going to go ahead and take a look at some of those questions. Okay, so one of the things that we're seeing here is people are asking if there's a separate license for the probing. There is a separate license for the probing add-in, and there is a separate install as well for the probing functionality, so that you will need to contact us about that. For information on pricing, you can see here is you can reach out to Inside Sales at dptechnology.com and we can get you some information on pricing. Another question that's being asked is if this presentation will be made available. This will be made available. We are recording this webinar. So you will have access to this webinar presentation in the future, definitely. Yes, so it is available now. The Renishaw probes are supported almost in full. Most of our corporate posts are already set up to support the Renishaw probing functionality. Yeah, so probing is definitely available in TNG. It's fully supported in TNG. We are working on that and developing it as well, so that's definitely coming out. So one question was if there's the ability to support if-then cycles. So I'm going to go back to the ESPRIT here, and every one of these operations here, if I go ahead and open one of them, there is a tab here for custom codes, and you can actually input any sort of extra codes you may need. So if-then cycles you can put in here, and each one of these boxes kind of controls the position of where those extra custom codes would get entered. One question we're seeing is if you need a solid model to do the probing. You do need a solid model to do the probing. We need the 3D input. So the one that we just went over here was a Renishaw probe. We are actively developing cycles for other probes and probe companies. So if you submit requests for that, we can look into getting support for the other probing options that may be out there. One question was, does this support a multi-point stylus? Yes, it does support multi-point styluses. Yeah, so one question is they want to see more in depth of updating the tool offsets and work offsets. So I can actually go over that right now. So this is more for like a single touch probing cycle, but on this probing options tab here, so there's a lot of options here for defining your experience values here, percent feedback, different tolerance values. But up here at the top, if you want to update a tool offset, you can set this to yes. And then pick the tool that you want to update, and then you can actually enter in a value here. Right now it just pulls the tool offset value that's currently defined in the tool, but you can adjust this if need be. Same thing with the work offsets here. So if I cancel out of this real quickly, you can see I have an H1 listed in my work offsets here, my work coordinates, and then I also have an H2 and H3. Right now everything is under H1, but if I were in a single point operation, a single point, I can do update work offsets, select the work offset that I want to update, whichever one I need. And then you can actually type in whatever value you need. So if it needs to be in H1, you can kind of see how that gets output. If I hit tab, it's updating this S value down here. So you can see a preview of how that works. And I'll go ahead and just post some code real quick and we can take a look at that. It's a large file. There's a lot of operations, so it's just taking a second to create my NC code. Okay, it popped up here. So here you can see I had 2 probing operations before all of my actual cutting cycles. And then it'll get into my cutting cycles here. And then if I scroll down to the bottom, I should see all of the extra probing cycles that I just created. Starting here, we had bore/boss cycle, 2 bore/boss, and then there was a 3-point as well. Here's my 3-point, my corner routine, my web and pocket routine, and the last web and pocket routine. So one question is, once the probing cycle has been completed and run, can the probe data be used to make wear offsets? And no, this would require a third-party software. Caron Engineering has a product that can do this. We will be doing an event series with them this year, so be on the lookout for that. Pricing will vary on the probing function. Again, for any information regarding the pricing of the probing function, you can contact inside sales at dptechnology.com, so that email address that's up there, and we can get you more information. It does vary on the probing functionality that you're looking for. So one example, or one question was probing raw stock, and I'll go ahead and go back to my file here. What I'll do is I'll just turn on the raw stock model that I have set in this file. So here is the raw stock that would be used in my file. And then what I can do is I will define a rectangle operation here. Probing elements, I'll select 4 sides. You can also select the top loop. I'm going to go ahead and select the 4 sides. And let's see. Just had to adjust the depth there a bit. And then you would maybe want to do an extra clearance here of maybe like 50 thou. And then that would be it programming or probing for the raw stock there. So that would be your operation. Again, there would be more details in here, but that's just kind of a general overview of how you could probe raw stock as well. Once you create this operation, you would then want to move it to the top of your operations list, just like when you're moving any other cutting operation from within ESPRIT. So another question is, will the routines output under a tilted working plane definition for 3+2 work? Yes, you can program the cycles anywhere there is a work plane. All right, guys, so we're going to go ahead and wrap up the webinar. If we didn't get to a question that you wanted answered, you can always email support@dptechnology.com, and we will answer any questions there that you may still have about the probing function, and look for more of our webinars in the future. Thanks very much.